Today we'll talk about a very useful technique in embedded systems programming, which is known as linked list manipulation. And specifically, we'll talk about a doubly linked list and why a doubly linked list is more interesting. And the reason it's interesting is because in a doubly linked list, you're not just pointing to one person, you're actually pointing to two people. So let's look at the implementation. The implementation is right now here in front of you. We have a data, and then we have a struct node star next, struct node star prep. As you can see, that part is easy. So you got a node. Now we have to allocate this node before we go to the deletion and all the other manipulations. So I have here a function known as add front, which basically takes the head pointer and the new data coming in, and first thing it does is actually allocates a node. And when it allocates a node, as you can see, new node equal to node star malloc size of node, it actually, and after that it initializes the new node with the data coming in, and it initializes the preb and the next pointers preb. So the preb, because it's at front, that means you don't have anybody in the before you, so you just say prep to null, and you basically take the current head and put it in the next pointer. Now when you do that, then you have to update the head also. See, if the head is not null, see, if the head were null, you probably can simply say star head equal to new node. Just update the head to new node. But if the head is not null, then that means you are not the first guy on the linked list. So that means you also have to make sure that the previous pointer of the head, whoever the head is set to the new node. Now why is that a case? Now you think about it. The star head is, now for example, you don't know if the star head is, if the star head already has a value, then new node next is set to star head, and now after that you just have to make sure that so basically the head is no longer, if you think about it, is not no longer the first node, because is the new node next is pointing to head, so the new node is now the head. So if so that's why this line is star head equal to new node. So as you can see, why the star head is equal to new node line is such a important line. In fact, that line is there also in a singly linked list case, right? Star head is equal to, especially when you're adding to the front, you just have to make sure that the head is now the new node that's coming in, where you're always going in the front. And if you think about, if you were the first guy coming in, that means no, you were not the first guy coming in. See, if the star head is not equal to null, that means star head prep equal to new node is also very important, because the guy next to you has to point back to you, right? So that is why. So star head prep, because if the star head was the first pointer in first node in a doubly linked list, then obviously you might say that why we need to manipulate prep. That's why we have the check if star head not equal to null, meaning it is no longer the null pointer anymore. When we came in, we see that star head is not equal to null. It is actually something, and since now we are making it not the first node, it has its previous node has to be put back to the new node, right? Whereas if the star head was null, then what would have happened? If if star head was null, then new node next will be set to null, right? And obviously if that is the last node, basically in that case uh, it will end up becoming the node after, and in that case null, right? Null pointer. So you can't do that in that case. Null, you can't dereference null pointer, it's prev or anything like that, and that is why there is check star head not equal to null, because before you end up doing star head prev, you have to make sure that star head is not equal to null, because if star head was null, we were the first guy coming in, and you start doing this line number, let's see what line number it is, set new line number, you start doing line number 50 actually, you'll immediately get a crash. So that is why this check is very important. If is star head not equal to null, meaning when you called at front, there was already at least a node in the list. List was not, you're not the first guy coming into the list. So star head is not equal to null, and that is why the previous pointer has to be pointed to the new node too, because now you are the first guy. Whereas if you are the first guy coming in, meaning this condition is false at line 49, that means star head is equal to null. That means you will be the head and the guy next to you is null pointer. You are the first person to come on the list. If the guy head next to you is null pointer, you're not going to go and start using his previous pointer. So just keep these in mind. It's not terribly complicated, but it could throw you out of loop in the middle of a if you are doing this coding in real time. So keep that in mind. Now let's go to why doubly linked list is more interesting. As I said, you are pointing to two people. So if you decide to bail out, or the system decides to bail out on you, you got to make sure that people you are pointing to are not left in lurch, right? That means the guy, okay, so let's not just talk about the literature. I would say we have to also quote unquote literature or theory. Let's see the code actually. So the delete node. So if you, since you are being pointing to two people next in prep, and you are going to go away on a vacation to nowhere land, that means you have to tell the guy next to you and the guy next to you about the guy previous to you, and the guy previous to you about the guy next to you, right? So that is why you can see now what is the prototype we wrote for delete node. The prototype would be void delete node head pointer, but since head is a pointer and it could potentially end up being modified inside the function, we have to pass pointer to it. So that's why it's node star star. Don't get overly worried about star star. Think of it as like any other thing, except like imagine if you have to modify a number inside a function, then you pass pointer to it. In this case, the number happens to be pointer, so you pass node star star. So think of this node star as a type in itself, and you're basically passing kind of a reference. That means one more pointer inside this function. We don't have references in C, so we have to pass pointer again. So it becomes but it's confusing. But in theory, it's just passing the head, which could end up being modified. I mean, other approach could have been that you return the new head or something like that, if it gets modified or not modified, but you return the new head. But we actually chose this void. The function returns nothing, but it could change one of its parameters in the calling in the outside code, in the code that calls it. So now you see the base case. The base case is if star head. So first of all, before you start doing any kind of manipulation inside a function, you got to always make sure that you take care of the error conditions. Don't assume that your parameters are good parameters. So first thing you got to say is, which you could do pretty much your eyes closed. If star head equal to null or del equal to null, if any of these pointers that are coming in, so why did we say star head equal to null? Why not head equal to null? Because that's actually the thing that is coming in from the outside, and that is why we had to do node star star. So if star head equal to null, then or if it's del equal to null, the thing that is to be deleted, no, that's a node star. If any of these are null pointers, then we just return base case. We call it base case, even though it's not like recursion or anything. Now you see, on the other hand, so before we go, I guess before we diverse and we give more stories in this podcast, let's make it. Let's finish this delete node code. Now you see, in line 20 we say node to be deleted is head node. Now, after we have taken care of the error conditions, we say, hey, what are the things that can happen? The node to be deleted could be head node, it could be the last node in the linked list, it could be the node in the middle, right? So we have to say if node to be deleted is head node, then what is the problem here? Well, why can't it be considered like any other case? Because in this case, you have to update the head itself. So that is why the line that says star head equal to del next. Right? If star head equal to del, then star head equal to del next. So we are clear here. Now we could have gone out of the function at this point, but we can't, because see, as I said, a doubly linked list is more interesting because you got two people pointing to you. So you can't simply go away. You got to tell the guys previous to you, the guys next to you, that hey, I'm going to go away. So that's the line number 25, which takes care of the point, the guy next to you. He says if there is a guy next to me. So 25 says if there is a guy next to me. So del next, not, so if you are not the last person, that means if there is a guy next to you. So if del next not equal to null is another way of saying that there is a guy next to me. That means you got to do this line 26 magic, which is db del next prep. You're telling the guy next to you that hey, there's a that I'm going to go away on a long vacation and probably never return. So del next prep equal to del prep. That's clear. Now see, if you are if there's also a guy previous to you, so if del prep not equal to null, that means you got to tell the guy before you or the girl before you that hey, I'm going to go away. So del prep next equal to del next takes care of that thing, that condition. And finally you free the memory occupied by del and you return. So that's your doubly linked list, deletion of a node in a doubly linked list. I hope it's clear. Now why the doubly linked list is more interesting, as I said, you got few people, you're pointing to two people. So that means, hey, if I'm pointing to two people and I'm going to go away, sounds it's not a big problem. You can go away, but you, since you're pointing to two people, means that they are also pointing to you, right? So if they are pointing to you and you're going to go away, you got to tell them. So that is these two cases on line 25 and line 29 takes care of this. Del next not equal to null, del prep not equal to null, and so that's your delete node. Now singly linked list is, on the other hand, only one guy or maybe one girl if you are a more adventurous engineer. So if they are pointing to you, I mean you're pointing to just one of them. So now you're pointing to one person ahead of you. What does that mean? That means that if you try to go away on a vacation to nowhere land, and you got to just make sure that the guy pointing to you is told about the next guy, uh, the guy pointing to you is told, okay. So you see, in a singly linked list, you are pointing to somebody and you are going to go away. Now, you can go away if you're pointing to somebody, but somebody is pointing to you. They don't know you're going to go away. So you got to tell them that, hey, I am gone, and you got to point to the guy next to me. But you see, I know about the guy next to me, but I don't know about the guy previous to me. I don't know who could be pointing to me. So this sounds so now you see, even though you might say it's only one person to be updated, and it's simpler case than doubly linked list, but it's actually harder because why? Because you don't know who is pointing to you, and that's a major problem in singly linked list. And you have to have this information before you write your will for posterity. That means more work maintaining this information. Now, in real world, what happens is singly linked list implementations, they call this information like who is pointing to me as previous pointer. But since pointing fingers is considered rude, we'll have to keep it quiet for now. So you have to keep the information basically point who is pointing to you, not within you, but somewhere outside. And that becomes little bit more tricky than a doubly linked list because you got to maintain this previous pointer all the time. So that hey, in case you're trying to go away permanently, this previous pointer can be used to uh, get to the previous guy. So in that case, you say prab next equal to you next. So so that is why there's the singly linked list case. Now there are sycophants in the companies, and the flourish quite a lot. But we will thrive knowing who is pointing to whom and who should be updated before we go to nowhere land. And with these thoughts about singly and doubly linked list, I will leave you guys pondering over the subtleties of these two manipulations of these two kind of lists. Very popular. They are used everywhere. I've seen them. So this is not even a elite code kind of theoretical question and just created to just to test you. This is something real world software does all the time in system software or user software. So you got to keep these things in mind. And I hope this was useful information. And I'll see you guys next time. Bye bye.